Introduction to NodeMCU. Development boards such as Arduino and PIC microcontroller are common choices when prototyping new IoT devices. Those development boards are essentially mini computers that can connect to and can be programmed by standard PC or Mac. After it has been programmed, the development boards can then connect to and control sensors in the field. Because the I in IoT stands for Internet, the development boards need a way to connect to the Internet. In the field, the best way to connect to the Internet is by using wireless networks. However, Arduino and other microcontrollers do not have built-in support for wireless networks. Developers will have to add a Wi-Fi or cellular module to the board and write code to access the wireless module. On the other hand, if you go for onboard Wi-Fi, it will cost you more. Let us have a look to an open source IoT development board called NodeMCU. NodeMCU boards consist of Wi-Fi enabled microcontroller known as ESP8266, Wi-Fi system on a chip from Aspirative Systems, and the hardware is based on the ESP12E module. In addition to the ESP8266, it consists of the voltage regulator and in-circuit serial programmer. The term NodeMCU refers to the firmware rather than the development kit. Firmware is a term given to the software that runs from non-volatile memory on a piece of hardware. NodeMCU firmware is an open source project that provides an abstraction layer on top of ESP8266 Aspirative SDK. One of its most popular features is that it has built-in support for Wi-Fi connectivity and hence makes IoT application development much easier. Evolution of NodeMCU. NodeMCU was created shortly after the ESP8266 came out. On December 30, 2013, Aspirative Systems began production of the ESP8266. The ESP8266 is a Wi-Fi system on a chip which is widely used in IoT applications. NodeMCU started on 13 October 2014 when Hong committed the first file of NodeMCU firmware to GitHub. 2 months later, the project expanded to include an open hardware platform when developer Huang R committed the Gerber file of an ESP8266 board named DevKit version 0.9. Storage and power supply. The board comes with onboard storage of 4 MB and can be powered with a regulated power supply of 5 volts power supply. While programming, you can simply connect it with micro USB cable to the USB port of your PC for deployment as well as for powering the device. The board also has individual onboard push button named as RST and flash to reset and format the module. Comparison of NodeMCU with ESP8266. There are different versions of ESP8266 available in the market, ranging from ESP01 to ESP14. Among this entire available version, the NodeMCU uses ESP12E board. Let us take a situation if we would have chosen ESP12E instead of NodeMCU, then what would be the consequences? In order to put the code on the ESP12E module, we need a handful of extra components: a 3-volt USB to serial adapter and a specific wiring setup. Also, we will have hard time getting it on our breadboard because the spacing between the contacts on the side is 2 mm, not the standard 2.54 mm. Additionally, we need to purchase breakout board where we can fix the module, and the most daunting part is that we have to solder each and every pin carefully. And finally, when you insert it on the breadboard, it leaves no space either side to insert any jumper wires for sensors connection. In contrast to this, NodeMCU is basically plug and play. Different versions of NodeMCU. First generation, version 0.9 or V1. This is now outdated development kit and is sold with an outstanding yellow board and is very wide. It's 47 mm into 31 mm. This means that it covers all 10 pins of a regular breadboard, which makes it very inconvenient to use. The board is embedded with ESP12 chips with 4 MB flash memory. Second generation, version 1.0 or V2. The version 2 fixes the shortcomings of the initial board. It is narrower and fits nicely into breadboards. The onboard chip was upgraded from ESP12 to an ESP12E, but the memory remains the same, 4 MB. Version 3. Version 3 introduced by producer Lolin with minor improvements to the previous version boards. Among others, they claim their USB port to be more robust, which is based on CH340 chipset. It also comes with the same ESP12E module and 4 MB flash memory. Board type and pricing. After you finalize to start with NodeMCU, the next thing you need to consider NodeMCU Lolin or Amica. Many version 2 boards are created by or at least labeled with Amica. It is a brand name created by the Dutch Gerwin Janissen, who owns the amica.io domain. Although not officially part of the original NodeMCU team, Gerwin designed a name for the dev kit version 1 called Amica. The team liked it and adopted the name. Amica really seems to be the only producer which is 100% in line with the version 2 NodeMCU hardware specification. So finally, Amica is the endorsed producer and Do It and Lolin are not. You can get the Amica based board from Amazon or eBay in less than $8.